Hey, and welcome back to the Builded Basement. Today we're talking all about plastics, specifically plastic filaments, and some of the basics, some of the properties of plastic filaments for people that are just getting started with FDM printing. So let's take a not so deep dive into what you can be using and what's available out there for everybody to be printing with. So filament. There is a wide variety of filaments available. Everything from PLA, which you've probably already heard of, but there are also nylons, there's PETG, there's ABS, there's flexible filaments, glow-in-the-dark filaments, filaments that have stone in them, filaments that have wood in them, filaments that have copper in them. There's tons of different filaments. So what should you use? What's easy to use? And once you get past using those easy filaments, what could you use to do things that you may not have realized you can do with an FDM printer? So let's start off with PLA. PLA is the quintessential plastic that people use when they're doing FDM printing. Why is it the quintessential plastic? Because it's easy to print with. So PLA plastic can be printed at temperatures around 220 degrees Celsius with a bed temperature of about 60 degrees. Here's the thing, you don't necessarily need a heated bed with PLA plastic. So even the cheapest printers you can buy are printable with PLA, and you can get pretty decent prints. Now, what are the downsides of PLA? Well, it's a very strong plastic. When I say strength, and I speak of strong in PLA, what I'm talking about is the tensile strength. It's not strong in the sense that it will hold up to a lot of wear and tear because it will snap. Why will it snap? Because of the tensile strength. It's one of those things where, I'm sure you've heard the expression, whatever doesn't bend will break. That's exactly what happens with PLA. Now, what some people have done, what some manufacturers have done, is they've made PLA Plus, which is PLA with a plus symbol or the word plus after it. And all they've done there is add additional plastics, maybe additional chemicals to the PLA that allow them to have slightly different properties than a standard PLA. They may be slightly more flexible, they may be slightly more heat resistant, they may just have other properties to them. Now, beyond PLA, the next one I want to talk about is ABS. The reason I want to talk about ABS next is because ABS is my favorite plastic to print with. It's also the grandfather of all plastics when it comes to FDM printing. ABS plastic is strong, but it's also slightly flexible, which means it stands up to a lot of wear and tear. Now, some downsides. ABS does require you to have a heated bed. It requires you to have a hot end and go up to around 250 degrees and a heated bed that you can get to around 100 to 110 degrees. Beyond that, it's probably the easiest plastic to print with. It sticks to itself quite well, it sticks to a decent bed, and it sticks to multiple materials. You can actually smooth ABS with acetone, which means you can make very smooth prints. And there's tons of other things you can do with ABS. You can machine it. You can do literally anything. You can make things that can go into a car. You can make things that can go outside. You can make functional items that you can use in your day-to-day life. Not so much with PLA. It's more for trinkets, more for knickknacks, more for toys, we'll say. Now, ABS also does have a very close relative called ABS Plus. Usually when it comes to ABS Plus or ABS Max or ABS Plus with the plus symbol, again, just like with PLA, they've made additives into the ABS. Those additives tend to usually be to make ABS slightly easier to work with. Now, don't get me wrong, ABS is pretty easy to work with, but it is more difficult than PLA. Beyond ABS, my next favorite plastic to print with is silk PLA. And I'm going to really show you some silk PLA here in a minute. But silk PLA is PLA plastic with some additives in it that allow it to make it look silky, shiny. It's pretty neat. I do have problems with silk PLA though, because it tends to expand when you print with it. It has the same printing properties in terms of temperature as PLA, but that expansion when you do print with it can lead to it being a little bit more difficult to print with. Personally, I find silk PLA more difficult to print than ABS. After ABS, after silk PLA, after PLA, you have PETG. PETG has also become pretty popular. It's actually the stuff that they make soda bottles out of. It's very strong, it's very sticky plastic. It does require you to have a slightly hotter temperature than PLA. You're looking at about 235, 245 degrees, and a heated bed of around 80 degrees. PETG is known for sticking very well to itself. Actually, in some cases, PETG can stick so well to your build surface that it will tear it apart. Let's look at some plastics. So in front of me, I have a bunch of spools, but that's not really important. I do want to show you quickly some of these filaments and how they react. So here we have a flexible filament. Now flexible filaments are good for, you know, doing some things where you want something flexible. Maybe you want something like a cat toy or a dog toy or something that you're going to put on a keychain or something that just needs to be flexible. It could be nearly anything. Next up here is a glow-in-the-dark filament. So this is a Pla Plus filament, and what the plus is on this particular filament is an additive that makes it glow in the dark. It's pretty neat, but one thing you want to keep in mind when you're dealing with a glow-in-the-dark filament is that additive that they add to this to make it glow in the dark can be rough on a nozzle. You'll wear down your nozzles quicker, especially if you're using a brass nozzle. Right here we have some PETG. Now the neat thing about PETG, or PETG, depending on who you talk to, is it can be clear. Matter of fact, it can be crystal clear. And depending on the speed, temperature, and how you print with it, you can make items that are nearly clear in your final result. It's neat stuff, pretty cool. Next up, we have some ABS. Matter of fact, I have a couple ABSs here. I did mention it's my favorite. ABS is available in a wide variety of colors. There are tons of manufacturers that make it. My personal favorite right now is actually the Amazon Basics ABS. It prints really well. It's pretty cheap at about $20 for a 2 kilogram spool, and it works really well. I will say that the Hatchbox ABS is my least favorite ABS. Now this blue ABS, it's actually translucent, looks really, really cool when you print with it. Matter of fact, here's something I printed with that, and it's kind of hard to see the translucent on the video, but this stuff looks really cool. Light passes through it just slightly. You can see your fill in it, your infill. So if you got like a honeycomb or, you know, whatever you have for an infill, you can see it through this, and it looks kind of neat. My problem is that this is horrible. It cracks, it breaks, and it's not a layer item in terms of the failure on it. It just breaks wherever it wants. Hatchbox says it's ABS. I don't know if it really is. Silk PLA, like I spoke about before, shiny. Not my fan, or not a fan of it, but it is shiny. Some other ones as well. So let's take a close-up look at some of these real quick, and let's look at Silk PLA. Even though it's not my favorite, it is very nice. You can do some pretty neat things with Silk PLA. You can print some pretty things. I guess that's pretty calm or pretty things. You see right here, it is shiny. It's shiny in the spool. It's shiny when you print it. Now, one thing I did note, one thing I will note, is that I do find this more difficult to print with than nearly every other plastic out there. The problem with Silk PLA is when you print with it, it expands slightly. That expansion makes it difficult to print with, the way I feel about it. So although I do like the way it looks, I don't like the way it prints, but it is something neat. You can get some good prints out of it. Next up, let's talk a little bit about PETG. Now PETG, like I talked about before, is clear. It can be clear. You can buy it colored. One of the main things about PETG is the fact that it is very sticky to itself. Its layer adhesion is probably the ultimate. I don't know there's another plastic out there that has better layer adhesion. Now when you print with it, it's difficult to get a very, very clear print with PETG, but your prints will be translucent. You can easily get translucent. Now one of the biggest downsides, and I don't know if it's going to show up here, I guess it shows up a little bit, is PETG is known for being stringy, which means that when you print, whenever your head moves, it makes a movement, even though you may have some retraction on, you're going to leave little strands of PETG in between your print points. You can minimize that by tuning and things like that, but it just happens with PETG, and you got to live with that. If you hit those little strands with some heat, either from a heat gun or a lighter or something like that, just really quickly, they'll go away for the most part. So it's not really that much of an issue. PLA is just plain easy. This is a PLA print that I did. I did it at relatively quick speed. This is a very nice PLA. This was done at 220 degrees. It's 1 millimeter. So I did this at a very high resolution, and I got a very nice print. Again, these things are sometimes hard to see on camera, but just for something like this, for something where you want to print of a bust or, well, let's call it a trinket. I mean, no offense by that. PLA is a very good plastic to work with. Now let's talk about functional prints. Now, my favorite things to print are functional prints, and most of that comes down to the fact that I really like building printers. So right now, I got a couple projects going on, but one of the main projects I have is my Voron Zero. Now, this piece right here is about 10 inches by 10 inches, and it's ABS. It's strong, it's flexible, and I don't know if there's another plastic that you could print this off with and get, you know, this type of result. Now, the thing to keep in mind whenever you're printing with ABS and any of the higher temperature plastics that makes them difficult to work with is the fact that they tend to warp. And the reason for this is the difference between the print temperature of the material, the bed, and the ambient air around it. See, what happens is as things kind of cool off, they contract, and as they contract, they pull. Now, you may have really good layer adhesion, which is great, but that same layer adhesion is the same thing that might pull your print off of your bed. The way to combat that is to have your bed at a higher temperature. It could also mean to print your product at a lower temperature. A lot of people don't talk about that, but sometimes there's a combination of those two things that you can make that allow you to print things without having them warp. This piece right here, again, very difficult to print in one piece. So difficult, in fact, that in the build, in the STL files for the Voron Zero, they offer that up in about a 4-piece, I think it's a 4-piece print. So if you can't print this way, either due to the size or due to the warping, you can print it off in 4 pieces. Getting to functional prints, this is a little camera mount that, or actually it's a camera enclosure and mount that I printed. Again, all in ABS. ABS, again, is great for functional prints. This is my Bob, or Build It Basement print. Take a look at that right there. So Bob, B-O-B, it's actually supposed to be an I up here, so this being the base of the I, that being the dot for Build It Basement, but looks more like a Bob, so I call him Bob. But there again, as a functional print out of ABS. Now, could you do this out of PLA? Of course you could. Would it last as long? I don't believe so. Matter of fact, I definitely say it wouldn't. Beyond that, functional prints with ABS can bring you right down the road to building something like a Voron printer. Now, I'm going to quickly talk about that. I'm going to talk about Vorons in general and building printers in general real quick, because I think knowing your filaments and buying something like an Ender or you know, a sub $200-300 printer is kind of a gateway drug to FDM printing. And once you get into it, if you enjoy the function of being able to print something, at some point you're probably going to want something more. Now, when you want something more, I suggest you do look into building a Voron printer. When you build your parts for your Voron, or you print your parts for your Voron printer, you're going to want to do it in ABS. Now, the reason for that, for the most part, is because of the temperatures that you can print with. Think about it. If you print your parts for your printer that can print different types of plastic, any plastic you print that has a higher temperature than the plastic that you've made your parts out of is probably going to fail. So that's the primary reason why you want to print your printer parts in a higher temperature plastic like ABS, like with a Voron printer. Now, you can print parts in nylon or polycarbonate, but there are drawbacks to those plastics as well. Now, don't get me wrong, polycarbonate and nylon are great plastics to work with, especially if you need something bulletproof. As a matter of fact, I have a video about bulletproof polycarbonate where I go ahead and try to destroy a piece that I printed. If you want to check out that video, go ahead and check out my backlog. Hit that subscribe button while you're at it. So, all in all, that is a quick rundown on plastics for your FDM printer. Now, if you have other plastics you're interested in, or if you have questions, by all means, leave me a comment, send me an email, or if you see me on the street, ask me. Hopefully this has been helpful for you. And if you do like this content, again, do hit that like button, do hit subscribe, and I'll see you next time.